Okay, so lesson 2.5 is using linear models. Now, if you're saying, whoa, wait, how does this relate? It very much relates because the first half of chapter 2 was all about linear equations. You know, y equals mx plus b. So slope, intercept, point, slope. All of what we did was about linear equations. Now, what we're looking at today is using linear models. You would have looked at this back in Algebra 1, talking about scatter plots, looking at positive, negative correlations, being able to look at the relationships, and that's what we're looking at today. So in the notes, we're going to talk about what it means to have a positive or negative correlation or no correlation. We're going to practice, technically there's 4 scatter plots. We're going to practice like with 2 scatter plots. We're not doing all 4 of these because that's way overkill, okay?
No.
But we're going to do like 2 of them. And then we're going to talk about whether or not they're positive or negative correlation, review how you know that. And then we'll also, the one we do on the back, we will go back and review how to write the equation of a trend line. So that is how to write the equation for a line going through the dots. So how to write an equation like in slope-intercept form. Okay, so that's kind of our plan today. Obviously, in Math Excel, you won't really be making the scatter plot so much as more answering questions over them. So, but, okay, positive. What do you guys remember about positive correlation? Positive? How do you know it's positive?
The direction it goes in.
Okay, so as we look at a group of dots, they're moving up and to the right. As you move across the graph right, the dots are going up as well, okay? So what that's really saying, you guys are probably looking at the visual of, okay, my dots are moving up, right? Moving up to the right. What that's really saying is as the x values are increasing, the y values are increasing. So generally speaking, as your age has increased since birth, your height has increased since birth. Okay, notice how I phrase that. We're not talking about what you're doing right now, but, as your age increased, your height increased. Okay, so that's the idea of a positive correlation. Both the items are increasing. Now, this first one shows a picture of a strong correlation where the dots are more tightly pulled together, or the points, I should say. The second graph shows it's still a positive correlation, but it's a weaker correlation. The points aren't quite as close together. Okay, so the opposite of positive is going to be negative. As you look at the picture,
your dots are going down to the left.
Okay, my dots are moving down to the right. Okay, so I would say, here's what I'm going to say. As I move to the right, my points are moving down. Which really what that says is as my x values are increasing, because as I move to the right, my x's are increasing, my y's are decreasing. And so what really happens with a negative correlation is I've got one item moving up and one item moving down. Does that make sense? So a negative correlation has 2 different directions happening. Just like with the positive, you can have a strong negative correlation where the dots are pulled tightly in. You can have a weaker correlation where the dots are not pulled quite as closely in. Let's see, a negative correlation off the top of my head. I didn't think about this ahead of time. Huh? Okay. Let's see.
So what's increasing? Your x's are increasing?
Well, and really as long as one of the variables is increasing is what, what we're talking about here. I'm trying to put that.
All I can think of is car.
The amount of gas in your car per mile strike.
Car and gas is all it's like in my head. The amount of miles.
Okay. So if we go that way, the more miles you drive, the more the gas decreases, so the less gas in the car.
Yeah.
This is assuming we don't stop for gas, right? Before anyone throws it out, but no, just, No buts. Don't, you know.
But
Yes. It will decrease. It'll be a negative correlation until you put gas in the car. But even then, it's still a negative correlation because the more miles you drive, so the miles you drive, as those increase, the amount of gas in your car decreases. That works. Okay. There's lots of different ways we can go with that. So, the final example, it's no correlation. Okay. The dots are everywhere. Okay, so here we can talk about your age and the length of your hair. You know, as your age increases, does the length of your hair increase or decrease?
yes,
It depends on your mood, right?
yes.
What's the style? Do we want long hair? Do we want short hair? I could say, are you male or female, but that doesn't really affect anything, you know, because you see just as many boys with long hair anymore. So, you know, but the idea, well, you didn't used to. It used to be, it used to be like a big no-no for boys to have long hair.
Listen, I know it.
So, but, okay. So, let's look at problem 1. Okay. So there's a big old open space here, right? Right. We're going to make a big old scatter plot in this open space.
Darn it.
Okay. Now, these are not the most fun numbers to make a scatter plot with. I will be honest. I understand that. But it's the concept of knowing how to do it and how to set it up. Okay? So, notice the table lists average monthly temperatures and electricity costs for a Texas home in 2008. The table displays the values rounded to the nearest whole number. Make a scatter plot, and then how would you describe the correlation? Now, here's one of the big things I have to note. There's 2 sets of data here. Well, it's 1 set of data, but it's kind of broken into 2. So, in January, average temperature was 61. The bill was 150. In February, 58 and 139, so on and so forth. So, as we set this up, we have to think about what goes on the x-axis versus what goes on the y-axis. So that x-axis is the independent variable. Okay, it's a variable that does its own thing, and it's causing whatever is on the y-axis to change. What's doing its own thing here? What's the independent variable? The temperature. Do we have any control over the temperature? No. So the average temperature outside, okay, we have control over the temperature inside, but the average temperature outside is going to be our x-axis. That's always the x-axis. Whereas our electric bill is our y-axis. So, I'm going to, let's see, I'm trying to look at how I've done this in the past. Are we not liking the fact of these temperatures? Did we just figure out it's Texas back there?
Yeah.
I don't like it at all.
What was? Yeah, the temperature on the outside is going to affect your electric bill because it's going to affect how much you run the air, the AC, the heat. We're in Texas, so we're probably talking AC more. Okay.
I don't know, it's only 61 of them.
Okay.
And 58.
So along the bottom, I am putting average temperature in degrees Fahrenheit. And notice, I am labeling the axis, yes? Along the left is going to be my electric bill. And that electric bill, of course, is going to be measured in dollars. Okay. Now, as we set this up, what kind of range of values of numbers do I need to have on the temperature axis? How high do I have to go?
85.
There's an 85. So we're going to have to label at least up to 85. How low is shown here?
58.
There's a 58.
About 55.
So here's the deal. We can start and we can label from 0 to 85 and 5s, 10s, whatever. Or we can do what I call as a break in the graph. And I know you've seen it before where it'll be just kind of like a little jagged thing at the beginning, indicating, okay, even though we're supposed to start at 0, we're not going to. We're going to start at something that would include 58, yes? Now, you can do
55.
yours how you want. What I've done on mine is I'm starting at 58 and I'm labeling by twos. So like my first number is 58 and then 60, 62. I'm putting the little tick marks to notice for each thing, right? And I'm not going to count these out loud because I don't want to mess people up. But I'm just counting by twos. So mine, I went from 58 to 86 labeling by twos. If you want to do yours differently, that's fine. Now, what about my electric bill?
The lowest is 110.
Lowest is 110, 255. So do we want to label from 0 to 255?
Yes. Absolutely.
Okay. I'm going to do another break, which is just kind of a zigzag indicating that's just kind of a visual like, okay, we're not starting at 0 here.
Absolutely.
Okay. I've been counting by tens, starting at 110. And I sometimes go up into my chart there. So either squeeze them together real close or you're going to be up in your chart, and that works too. So 110, 120, so on and so forth. Okay, I just did 110 to 260. I managed to squish it in together just enough so I just beat the chart. If you didn't, if you ran out of room, I don't care if you label up into the chart. I've done that in past years. I always have a set of past notes beside me and, you know, I've done that in past years, so. Okay, so now what do I do here? Gotta mark our points? So where's our first point going to be at?
61, 150.
61, 150. So we're going to go right 61 and then approximately up to 150. Obviously, is this going to be very precise? It's not going to be exactly precise, but that's all right. It's still going to give us the idea of what the graph should look like. Then I'm doing 58, 139. So I'm going over to 58 and stopping just about 140. 67, 172. So I'm there between 66 and 68. What did I say? 172. So right above 170. 75, 205. $79, 170. $83, 234.
Bingo.
And we're not done because we're going to do the other column.
84, 250.
84, 255. 85, 245. 81, 210. 76, 183. 65, 132. 58, 110. Okay. Does your scatter plot look something like my scatter plot?
Similar.
Yeah.
Okay. Okay. It should look similar. When you get done, you end up with 12 points. Okay. And one of the questions we're being asked, how would you describe the correlation?
Positive weak.
Can we at least agree that it's positive?
Yes.
Okay. And that's the most important thing to me, is that we can agree that these points are together moving up to the right. As the temperature is increasing, generally speaking, the electric bill is increasing. And that makes sense, doesn't it?
Yes.
Because if we're going, the higher the temperature is out there, the more you run your AC inside, and the more you run your air conditioner inside, the higher that electric bill goes. Okay? So if you have parents that are constantly trying to turn the air, not make it quite so cold in your house, you'll understand why. You'll understand why these days when you have to pay the bills, right?
Maybe.
Okay, so it is a positive correlation. I don't know. I honestly think it's almost kind of a strongish correlation.
Maybe it's just mine looks weak.
Well,
Almost
okay.
weak.
Maybe it's just mine.
Okay, and I'm looking at my paper, you're looking at your paper. Who knows? Maybe mine's supposed to look weaker than what it does. Okay, before we move on, there's a question right down below your graph. I don't know if you saw it or not, but how much would you expect to pay for electricity if the average temperature was 70 degrees Fahrenheit?
180.
Okay, you guys are throwing numbers out at me.
180.
Okay, give me some reasoning for these numbers you're throwing out at me.
Well,
Kylie?
The way the graph looks, if you go to 70, you can kind of just line it up and kind of guess.
Okay, so she's like, the way the graph looks, you go to 70, are you just kind of like lining up and saying, okay, it's going to be in this area?
Like 170, 180.
Okay.
I'm
Now,
saying 180.
and Kylie's saying 170, 180, and I don't know if she's looking at my graph or her graph, but
I just had to look at your graph because mine's not great.
okay, here's the deal. Are we all going to be identical?
Yes.
Generally for
Absolutely.
We're not all going to have the identical, depends on the graph you're looking, it's not all going to be identical. However, should we be in the same ballpark?
Yes.
Okay.
$181.
Now, one thing you can do, and so I love my Rose-Hulman rulers for this because it's clear and it can help me, If I try and draw a best fit line through here, okay, and I'm not, I'm just trying to, I don't know, let's see, if I just do this in pencil, does that line look like it kind of splits the dots?
Yes.
Okay. And kind of with what Kylie was trying to do. She was just kind of eyeballing, right? Now, we were specifically being asked for 70, yes?
Yes.
So if I go up to 70, and then what am I trying to do?
So about 175.
170. And my line kind of went down there, I think,
It did.
I'm in the ballpark of 170-ish, right?
So 170.
Depending on your graph, could you maybe say
72 cents.
180? You can obviously be higher or lower, yes? So, honestly, if I probably should be more about 175 or 173 or something.
So 173.75.
See, like mine looks like 185. So.
Okay, and here's the deal. If your graph backs that up, I understand that. Okay, so this is more about being in the right ballpark. Okay?
Mine's like 160. Mine really stuck.
170.
I'm going to put 175. my graph kind of leads that a little bit more. But do you understand what I did there? I drew in that line to kind of indicate what we were looking for there. Questions on that one?
You have to
You probably wouldn't.
start it. Watch with that.
Okay. Before I flip to the backside, we're not going to do this scatter plot, but I just want to talk about what the correlation would be. So the table shows the number of hours students spend online the day before a test and the scores on the test. Make a scatter plot. We're not doing that. How would you describe the correlation?
Negative. Maybe.
So, as you look at this, and I always tend to put increase on the first item. As the number of hours online increase,
your test scores decrease.
what's the other item doing?
Your test scores decrease.
So as these are increasing, my test scores are
Decreasing.
decreasing.
So it's a negative correlation.
And so that represents negative correlation.
Yes.
So do we always have to make the scatter plot to answer that question?
No.
No. You can use what you know. And in this case, based on the numbers in the chart, the fact that, okay, those numbers of hours as you move across the right are increasing. But the test scores as you move across the right are decreasing. Kind of goes along with the idea of, however hard you study, that can, pay off a little bit.
I don't study.
When it says spent online, I thought they meant like online studying.
Okay.
I
No.
was confused.
This is like the number of hours spent online on social media accounts.
I figured that out, but I was
Yeah. Like, okay, how often, how long did you spend on TikTok? How long did you spend on Snap? How long
I
did
could tell you exactly
how often were you on Instagram?
I got to show you this my TikTok I saw yesterday.
Okay, so,
Still laughing. Yeah, I was like really confused. I was like, why would you study more?
okay guys, flip it to the backside, please.
Oh, no, I feel like studying hurts my brain.
My mom just sent me TikTok.
Okay, reel it back in. On the backside, we are specifically writing the equation of a trend line. The table shows the median home prices in Florida. What is the equation of a trend line? So that's one of the things we're going to have to do. What is our most used equation of a line?
Y equals mx plus b.
There we go. So we're going to write the equation of a line, y equals mx plus b, that models the relationship between time and home prices. And then we're going to use the equation to predict the median home price in 2010. Okay.
How long ago were these notes made? What's up with these years?
Well, we're on the last year of this book, and honestly, a lot of these notes were used with the previous book too, so.
Okay. The book's expired?
It says predate.
No. This is
like from 11 years
books are on a 6-year rotation cycle. So this is the 6th year that we're using this book. But possibly. Yeah, I don't know what our plan is for next year. Okay, guys. Come on, focus. I want to make sure we get through this, okay? Now, as we set this up, we are going to the whole idea here is we're going to set up a scatter plot. We're going to draw that trend line, but we're going to come up with an equation. So we're going to be a little more official than just trying to put a dot on a line like we did on the front side. Now, as we set up this graph, on the bottom, the x-axis, what's the independent variable? The year, because time is always an independent variable. We can't control time. The median price is going to be the y value. Now, what I am going to say, and I'm going to do kind of what the book does here. The first year here is 1940, yes?
Yeah.
And to graph something like 1940, 1950, 1960 is a little more awkward. So what the book does is they're going to call 1940 year, not 1,
10.
year 0. Now, think with me. If 1940 is year 0, what's 1950?
Year 10.
Year 10. because it's 10 years. There's a 10-year gap, right? I get it. You guys are wanting to say just 0, 1, 2, but we have to go with there's a 10-year gap. Okay. So what's 1960?
20, and then 30, and 40,
Okay, we got it now.
50.
Thanks, Justin. Appreciate it.
You're welcome. You're absolutely welcome.
Yeah, we know.
What would we do without Justin?
And then,
I'll probably die.
okay, 2010. When we get to that later, that's going to be year what?
70.
70.
Two.
Because what we just did is we labeled the number of years since 1940. If 1940 was year 0, all of the rest of these are, okay, how many years after 1940? So if I all of a sudden want to ask you about, 2030, it's the years after 1940. Okay, I'm going to again use this whole space to make a graph. Along the bottom, I'm going to label it number of years since 1940. You can't just put year 0 on there and not say what it is. Okay? Number of years since 1940. Along the left, this is going to be our median price. And of course, that median price is in dollars. Along the bottom, what would be smart to label? 0, 10, 20, 30, 40, 50, 60? Label by tens, right? Do we need anything in between the tens? No. Okay. Along the left side,
Oh, yeah, you're wrong.
we have to go as high as
105,500.
105,500, as low as 23,000, which in that point, we're not too far off from 0 in respect to the fact that we have to go up to 105,000. So, I've been doing 10,000s, but with like a tick mark. I guess technically I'm labeling in 5,000s, but I'm doing a tick mark in between. Okay, so let me explain that. That's something. So I'll do like a tick mark and not label it, a bigger tick mark and label it, and this is my first one, so that's 10,000. Does that make sense? Let me zoom in a little bit so you can see what I'm doing here. So a tick mark, not label it, which would be 15, and then this next one that's labeled is 20. 30, 40, I missed something out there, 50, so I'm labeling every other mark there, 60, 70, 80, 90, 100,000, and my top label ends up being 110,000 because that gets me past 105.5. It is. Okay, we need to label or put your dots in, right? Okay, so 1940 is year 0, 23,100. So on year 0, I'm going to put a dot at approximately 23,000, which for me is on the y-axis, past 20 before I get to that tick mark of 25,000. $1950 is year 10, and I'm going to go to approximately 40,000. 1960 is year 20, and I'm going to about 58,000. 1970 is year 30. 57.6. 1980 is year 40. 89.3.
I didn't even write 30.
50 is at 98.5. And 60 is at 105.5. I don't really like how mine's looking, but that's all right.
It's okay, but I went through the chart.
That's fine. Okay. Okay, definitely a positive correlation here, yes. As the years are increasing, the median prices of homes are increasing. Okay. Now, as we think about an equation here, okay, so first of all, I'm going to try and draw a line in. And as I draw a line in, I kind of want my line going through the middle, right? I kind of want some dots on both sides. Let's see. I'm not 100% happy with that line, but it's a line. Okay? Here's the deal, guys. On this specific one, if you recall, we were asked to write the equation of a trend line. We're writing the equation for a line that fits this data. So we're going to write a y equals mx plus b equation. Now, most of you just took a quiz over this. What do we need to write an equation?
A slope.
We need a slope. What do you need to get a slope?
Rise over run.
A rise of a run, which means we need 2 points.
2 points.
Okay?
72.
2 ordered pairs. So you've got to pick a couple of points. And this is where one of those things, technically, I know you guys are probably all going to follow my lead on this one, just do whatever I do. But technically, if we're doing this all on our own, are we all going to have the exact same points necessarily?
Yes, absolutely.
Not necessarily. Okay? And so there's going to be a little bit of variation. And I understand that. Okay? Now, Math Excel, you won't have this issue. Okay? Based on what they asked you to do. One of the points that would definitely be best to use. Why is this a good point to use? It's also the y-intercept, isn't it? Okay, so one of the points I'm going to use is the ordered pair 0, 23,100. Okay, so that is one xy ordered pair. And it's perfect because it's already the y-intercept also. Now, for another dot, the way mine worked out, it went through this dot right here, which is the 50 and 98.5. Okay, so those are the 2 dots I'm going to use. Remember, in an ordered pair, it is always xy, xy. How do I find slope? Y2, I'm going to use 98.5 minus Y1, 23,100, divided by X2 minus X1, 50 minus 0. So I did 98,500 minus 23,100 over 50 minus 0. 50 minus 0 is 50. 98,500 minus 23,100.
Big number.
75,400 divided by 50. 1,508. So what is that 1,508 I just found?
Your slope.
My slope. So M is 1,508. What's B?
23,100.
my y-intercept, which was 23,100. Can you write an equation?
Y equals
Y equals mx plus b.
X
Y equals 1,508x plus 23,100. Now, we've got one more part of that problem to finish real quick. Because it asks one more question up there.
I see it's about,
The year 2010.
see it's about 10,000.
Now, okay. You've got your equation, right? The question was, use the equation to predict the median home price in 2010. Use the equation. So am I just eyeballing it on the graph?
No, you are going to plug in your number for X.
What number am I plugging in for X? 70. Because 2010 is 70 years after the year 1940. So, y equals 1,508 times 70 plus 23,100. What is 1,508 times 70?
70 is 105,560. Plus 23.
So 105,560 plus 23,100?
128,660.
128,660.
It's a lot. I wish I had that kind of money.
Okay, guys. What I've done today is I've spent today just, okay, how do we make a scatter plot? How do we look at the equation? How do we use the scatter plot to help us? How do we use it to answer questions? Okay. Math Excel, if I recall, is going to be more about answering the questions and whatnot. If I recall, I think it's a pretty quick assignment.
Multiple
I
choice.
could be wrong. But, so you need to get lesson 2.5 done for tomorrow. Okay?
Yes, ma'am.